state-of-art numerical analysis with the remote sensor for analyzing the stability of soil. These two topics, I should give one introduction. These two topics are nowadays a very, very important problem for Indian mining industry. Because in India, you know, our coal production is more than 600 million tons a year, and it is going to be increasing in 5 years, a large quantum jump. And this production, majority, if not 90%, maybe nearly 90% of its production is coming from open cast mining. So it is very definitive that tomorrow or day after tomorrow we may have to go for a deeper open pit mining. Only may we have to go. So this deeper open pit mining, please close the door. I am waiting for you all. So this deeper mining, deep mining, posing a very large question on the existing technology what we have. Though we will brush up through, we will go through different existing methods that is available in the books, but beyond that we have to think about. Because in this domain there are a lot of work is going on, and there is good contribution from industry also nowadays we observe. So the problem of the stability of slope is a very long problem in that sense, because not only mining engineers deal with it, civil engineers often have to deal with these slope stability problems for building large and small medium dams. And for the highway authorities, they have to take care of this very important topic. So this stability of slope, I was in a contradiction what domain I should focus, because the analysis type in soil, analysis type in medium or medium to soft rock or very strong rock is very different. Approach is very different. So it is better we should first go through what is there in the general textbook, generally we learn. So that from that we will try to understand what need to be taken care of if we want to do something else. So I have planned accordingly. So I have planned accordingly. We will introduce you about the topic. Basically, this slope is engineered by. We are generally we will concentrate on the engineered slope only, because natural slope is more or less naturally stable, except you intervene. In the rock crest, in the Himalayan region, generally rock do not fail, except we interact with the rock, building roads, different kind of cut slope. Normally rock do not fail, natural rock do not fail. So it is basically the external condition, and an external condition is our civilization. This civilization itself creating a large problem to this kind of means actually adding problem to this existing problem already. So we need to take care of few things, not only technical. Technical means technical parameters we can consider, characterize, but also the economical one. Economical one in the sense, suppose in a hilly terrain, when we are building a road, if the cut slope is not stable, it will create a lot of problem in a long run. Frequent failure will occur, so it will create a problem to connectivity between the two cities, as well as it may halt the progress of the vehicle, and that it will in a long run it will affect the economy, because you have to again you have to take the remedial measures, you have to correct it, rehabilitate it, and it's a long run. So it's better. The engineering approach is better to design a safe slope. Better to design a safe slope. Initially invest more, but it will serve you for a long time. It will serve you for a long time, so that you can think of it. So basically, we generally, when we analyze the stability of slope, we generally consider the local stability. There is also concept of global slope stability. There are many other approaches. So we will try to go through that. So the aims of the stability of slope would be, we should, any structure, not only in slope stability, in any structure, aim should be to build a safe structure, means safe slope that will stand for a long time without any failure, without any accident. So that is our desired objective. So second is, depends on the purpose, depends on the time period, we will rely on that slope. Particularly suppose a mining, 10, 15, 20, 25 maximum. 25 years is the maximum lifetime of the rock slope in mine bench, and subsequently for tailings pond embankment as well as waste overburden dam. After that, no one will care about it because they will leave it. But consider, this is the condition in the outside. You have to rehabilitate all the places before the mining period as it was. So in Indian context particularly, generally in mining, they are only considering the stability of slope problem in a time range. Okay, for 10 years our mines will run, accordingly we will design. So actually we are compromising the stability of the slope. Second approach is, we observe already Bazant slope failure is a very famous slope failure. Most probably in Sweden or Switzerland, I don't know the country. It's a big problem, and lot of literature is available on that particular slope. Okay, how slope has failed and what was the possible reason behind that failure. So it is exhaustive literature is available for that. So that literature suggests something about how slope fail. Depends on the material characteristics. Means a slope composed of soil and rock mass, a slope composed of rock and soil mass, that will fail depending upon the characteristics of the material, not on external load. Remember, type of failure do not depend on the external parameter. Suppose there is an earthquake, suppose there is a huge amount of rainfall, that will not dictate the type of failure. Type of failure will be dictated by the material constituent, type of material present in this slope. So it's a very important parameter. We need to know what type of possible failure may occur in a slope, so that I can assess based on that type of failure what could be the possible and the maximum deformation time sequence. So that is very important parameter we need to know in stability of slope. Another important parameter we generally think of, one example I have already gave you, that is Rajon slope failure. So that slope failure actually help us to get some preliminary idea. If we do not take care of this type of parameter, might be in future our slope is going to face that similar consequences. So experience means transmission of the experiences from the time. Suppose in 2010 it is occurred, we are cutting or we are developing a slope in 2019, that experience will help. Definitely in all disciplines it's help. Then the last parameter generally we consider in a mining for a stability of slope is the dynamic load. This dynamic load generally comes from the vibration, the heavy amount of vibration that is daily basis occurred in the mining, and also if the zone is very earthquake prone, then there is a possibility that it is always experiencing some kind of seismic waves regularly. Whether that regular seismic wave is going to play an important role or not, that we have to characterize. So this could be the possible aims to do the stability analysis as an engineer who is dealing with the problem. There is a problem in the display and it's not clear. See? Start with basically the last one is not a type of failure, but it is a stray fail of rock in terrain. We are not considering that. So the first four is basically the type of failure we observe in slope. The first one, the plane failure, is basically the theoretical deduction of the possible modes of failure in a slope. This is for your information. This is a theoretical deduction of the possible type of failure could be observed in a slope. But in actuality, it's a very rare event. In actual, it's a very rare event because to categorize it as a plane failure, we have some conditions. We will deal with that. Few condition is there. If that condition satisfied, then the type of failure will be classified as a plane failure. So there is some condition. So that failure need to fulfill that condition. In rock, majority of the problem we are facing with the OH failure, because you can understand when two joint set intersect with each other, 2, 3, 4 intersect with each other, they will form a block. So that block is basically at all the side is disturbed. It is not intact. It is no more intact. So if there is a inclined plane along that, it is possible that that block may slide along the line of intersection. It is a possibility. So in rock slope, most of the case we observe it is a wedge failure. Few cases we observe is a toppling failure. There is in the classroom there are something that is easy to tell you how the difference between wedge failure and toppling failure. Oh, okay, no problem. Suppose three pencils are standing like this. Okay, it is inclined in this direction. So it is a possibility it will topple one after another. It will topple one after another because of what? Because of the alignment. there is no movement. There is no movement. It is only just flakes are disturbed like that. So in topple, difference between topple and the plane and wedge, in these two kind of failure, we observe a movement. We observe a movement. In wedge, we observe a movement. But in topple, it will just stop. So kinematic analysis for the plane failure, wedge failure will be of one type, whereas the toppling will be completely different. Basically, it's a very complex problem to represent it mathematically. Though it is also very rare. Most cases in mining we face, including low depth open cut, means shallow depth open pit mine, and other mining accessories, overburden dam, tailings pond embankment, ash dike embankment. These are the general structure being built due to different purposes. So in these cases we observe the circular failure. So fourth type of failure we generally observe, means these are the class of failure we are now going to categorize. One is plane failure, purely from the consideration that the failure will be along a plane. In wedge, of course it is along a plane, but it is along the line of intersection between the two joints. Topple is just, it is topple, there is no movement. So it is basically a rotational type movement, it will just topple. The fourth is circular failure. There is also a shear movement along the plane of weakness. Along the plane of weakness. Few condition is there, you will get this material, you will study it. One major important condition for plane failure is failure plane must strike parallel to the slope face. It's a very important consideration. Plus minus 20 degrees is allowed, but its strike must be parallel to the face. One condition. Second condition is friction angle of the plane of failure and the inclination of the angle and the inclination of the slope face, there is some combination. If the inclination angle of the slope face is psi phi, so psi phi is greater than the psi f, psi I along the inclination plane, and it is greater than the phi of the material friction angle. So there is some relation. There is another one important parameter we are negating, we are not considering, that is a very important parameter. One boy have asked me a question when we test the triaxial indirect tensile strength. He have asked a very important question. In a plane failure, when I am telling that one plane will move along another plane, it is just a plane failure. It is just moving. Here in the plane failure condition, there is a condition that there will be some release surface, because this is also a block, so it will move along a release surface. So this release surface will not offer any resistance. But we know any block when it is moving, there will be definitely some amount of friction. So except a very free face, it is a possible the release surface, this is the release surface, this is actually glued together, these two blocks. Now when it is moving, it is a release surface, so it is going to offer some amount of resistance. So in plane failure analysis, there is no scope to accommodate this resistance. So if there is a resistance, then no more, the type of failure will not be categorized as failure. Very important consideration. So that is why we do not consider type of failure plane failure for any field cases. But we analyze it. We use this method in maximum cases for other reasons. The derivation, mathematical derivation for the equilibrium, force equilibrium, moment equilibrium is very simple to derive. Very simple to derive. So, you will get a very large number of equations where it is solvable, not indeterminate. Equation is solvable, not indeterminate, whereas in the circular case, the equation is indeterminate. You have to perturbate the equilibrium condition, so you have to assume something. So, it is very easy to deduce the equation, mathematical equation that is actually contributing the failure. So that is why parameter wise, height, friction angle, cohesion, many other external parameters, you can directly analyze the sensitivity of each and every parameter that is responding to the failure of slope. So this is very important assumption we face in the type of failure in India. So this is typical a picture, you will get it. Now wedge failure, this is most common. One thing we need to acknowledge that to predict or to visualize the type of failure as wedge, you need to understand the steering. You need to understand the steering. Do you have the idea of steering? So I will just briefly explain in the board so that it will be easier for you. This is, if you consider it's a sphere, generally earth have longitude along this. So the drawing is not good, but you can understand. So this is a earth. Suppose it is a sphere, okay? So the sphere will take care of. Suppose this sphere is in this is a kind of sphere. It is there. Oh, it is, suppose it is transparent, and there is some line has been drawn in black color. So if I give a projection from the top, what you will find? This kind of dot points you will find from this side view. From the top view, what you will find? This is side view. On the top view, what you will find is basically this kind of top view you will get. So basically what I want to mean it, this is a 3D. This is a 3D object, this is a sphere. There is a black color being drawn in a transparent ball sphere. I am applying some light, so you will get this kind of projection system. So it is to understand that now from the 3D I can scale down into 2D. Same feature, suppose there is one point, this can also be represented here like that. So the idea is in the stereo net, all the feature which is present in the topography, in the surface, is basically in 3D. X, Y, Z is there. So to draw this X, Y, Z everywhere, it is very difficult. So why not to scale down it into 2D so that we will not compromise the other aspects. We may compromise the z aspect, but that is also it is very difficult, x, y. So people have thought that in Earth it is possible the Earth sphere can be made a stereonet. This stereonet basically a projection system to plot the 3D object in 2D, 2D object into point. 3D object into 2D, 2D object into point. So the advantage is that we can plot all the information present in this sphere in a graph of paper in 2D. And we know when there is the rock mass is heavily jointed, there is a large number of joint set. So joint have a two dimension, two parameter we generally describe. One is joint inclination, another is joint orientation. Orientation of the stripe. So we have two parameters. So there is some procedure. To draw a stereonet. There is some let down procedure for equal area stereonet we are considering. There is some procedure. It is north, it is south, it is west, it is east. The procedure is if the orientation 45 degree is the 45 degree is the orientation of the joint and 53 degree is the inclination of the joint. How will you plot it in this stereonet paper? Stereonet paper is basically like this. You will get like this. Stereonet paper is like this. So there is 10 count. So basically if it is start from 0 it will be 90, it is 180, this is 270 and again 360. So basically each will be of 10 count will be there, this count. So if it is 45, then I will come from north to 45 suppose here. Okay? Then I will rotate my stereonet transparent paper to the north, this original point, suppose this, we will rotate this point here, then we will count from the east 53, 1, 2, suppose this. Then along this line, suppose there is a line, I will plot, then I will rotate back. So it will look like, ultimately, it will look like this, maybe like this. So the joint, that is the 45 degree orientation and 50 degree inclination will look like this great circle in this stereonet. So people have thought of, okay, we have to summarize more. Okay, then plot the pole, just 90 degree opposite. So this pole will represent the joint. My point only. So what will happen? If we plot this stereonet, a number of poles here and here, here and here, here and here, so you can easily tell the joint set population is more here, so it is representative of joint set J1, J2, J3 population. So the help of the stereonet is, from the stereonet plot itself, you can easily assess where is the concentration, where the concentration is more for the joints. So basically this approach helps a lot for analyzing different problems related to the weight stability. In weight stability, we often use this stereonet to calculate initially the stability condition, because in the stereonet we have a let down procedure. There is some condition we use. Suppose wedge failure, suppose one plane A, suppose great circle is this one joint. So I am assuming that another plane B going to intersect it. So there is a line of intersection. The line of intersection means a linear feature, plunge and trend. So that would be represented by point. So the point feature of the line and the point feature of the pole is also different. We generally represent pole like this. Okay? So we have to remember that. So there is a condition that this line, suppose there is slope face orientation like this, and if you equally plot, suppose 30 degree your friction angle, 30 degree your friction angle, 1, 2, 3 like that. So from the center if you plot, then your line of intersection must lie between the slope surface, great circle, and the friction angle. So this is an easy problem to solve using the great circle. Generally, most of the people use it first initially to estimate whether my problem can be kinematically solved using this approach, or we have to use the software. There is one rock slope software is available. What is the name of the rock slope software for this wedge failure?
Rock science. Slide.
Huh?
Slide.
Huh?
Slide.
No, not slide.
Dip is also
Dips.
Actually dips, no? No. This is also for wedge. You can download. You will get at least 1 or 2 month industrial student version, full version, student version, and you can work on that. It is easily available for all the rock science product. I recently heard that rock science product is offered in discount for this kind of workshop. So this is actually the dynamics to analyze the type of wedge failure. I have to go fast because I have lot of material. I have to finish it today because I do not have any other class, so I will not get time. This is the possible geometry. So toppling failure, all the material will be available to you shortly. So just remember. So this is kind of toppling failure. Only for these cases we consider this kind of geometry when we observe in a structure. We generally nomenclate that there is a possibility of toppling failure. Circular failure is very, very important for the civil engineers as well as the mine engineers. That is, we are mostly deal with. In circular failure, the beauty in the circular failure is equation is indeterminate. I have already told you. Generally, what happens for a circular failure? Approach is, suppose this is a slope, approach is like this. So this is a plane of failure. We assume that okay, it is a failure, it is a movement, shear movement. So there will be some center of movement. So people try to analyze this with a slice. So this slice, virtual slice, not actual. So this slice indicates, this is indicates some soil mass, this is indicates some soil mass. So this slice basically indicates this is a weight, there will be some weight, self weight of the mass. So if it is an inclined surface, self weight will be divided, one into perpendicular to the plane, another will be along the plane. So for every slice, this kind of vector is possible, force vector, two type of force vector is possible. So if you want to add summation of the forces along the slope face and the summation of these normal forces is required for sigma tan phi. So sigma n will be repeatedly updated to have a sound shear strength of the shear plane, possible shear plane. So it will generate a large number of equations. That is why I am telling that you have this some large number of equation. Means if there is a 50 number of slice, you are going to get at least 100 number of equations. And 100 number of solution is not available to you. So that is in partial. There is another condition. So this is a block. So one block can have a shear over the other. One block have a shear over the other. It is possible. Not only that, if it is someone is standing in a stair, if large number of students is standing in suppose in a cinema house or in a station, what you observe when you are standing, basically you are applying some thrust force to your next person. Have you observed that when you are actually going down to the stair, actually you are giving some amount of thrust force to your next person. So horizontal thrust force is also there. Similarly, there is horizontal thrust force that will also give a third reaction according to Newton's law. So there is large number of equations going to produce you to consider this problem. So basically it is an indeterminate problem. So people have tried to solve using perturbating this condition, means they are compromising some of the aspect for few cases. That is why there are number of type of analysis being developed for this circular failure. Bishop, then Jambu, then friction circle is not so popular. Many I just don't remember. There are number of 10 to 15 number of criteria approaches is available in the book. You can find that. So this is I am going through. Now this is also the kind of slope failure you observe, and it's posing a large problem for the economy of our country also. Because suppose there is some falling or failure in the Sikkim Gangtok, so entire state is stopped. Likewise in the Himalayan region. So this kind of failure pattern, failure type are now being considered or approached by the civil engineers also to try to give the possible solution. Okay, so the possible solution, one of the possible solutions we are look for better design, fast. And if it is not possible to alter the design, then for strengthening. If there is no position to accommodate the change of the geometry, then we are going for strengthening. So there is only two ways possible, and people are working hard to come out with a good many ideas how to deal with this kind of problem, because it's a very active problem, very active problem. In Himalayan region, it's a very new rock, formation wise, seismically very prone. So continuously there is this source of disturbance, and human interference is also there. Now, in a mine, there are a number of parameters we have summarized, starting from the geometry, groundwater, dynamic force, temperature, many things. Nowadays, in the dam stability, I will come through that with little time. In the dam stability, nowadays people are facing a tremendous problem due to the temperature. Because in dam waste material, there is some amount of sort of shale and some amount of remnant of coal, and coal self, what is the terminology? Self combustion. Due to the self combustion, they get heated and overburden. From the overburden, we regularly see the smoke. Regularly we see the smoke, and it is posing a large problem to the mining industry. So I will go very quickly. These are the things you have already more or less learned. Spacing, these are the kinds. Groundwater, how groundwater will. These are the equation. You can go through that. We have tried to. These are the software you can use it. That is why we have used one student have told slide. It's a very good software. Earlier, many people use GIAN, but nowadays people prefer this slide. Okay. The GeoStudio is also another slow stability software being used globally. This is all are based on alien methods, limited methods. Then software based on hydro simulation, we generally use C of the hydro slope as well as hydras. In our case here, in numerical base there are many, though use of ANSYS is very limited in the rock slope or soil slope. FLAG is majorly used, UDEC is also used, PFC is also used, phase 2D and 3D also used, Flaxis is also used, and GeoStudio is common because GeoStudio also have a finite element package. Kinematic analysis is very few, I have given introduction. Now I want to switch over a few aspects of the topic. How groundwater will actually influence, we will go through very quickly. These are the possible regime, possible to be analyzed, to be considered, to analyze the influence of pore pressure in a rock slope. One is, if the zone is like this, that water is basically going down. Flow pattern is this. Flow pattern is this. So flow line is like this, and your equipotential line is aligned like this. So it is very safe. Whereas in this case, flow is coming to the pit bottom. So there is a continuous flow. So this type of slope need to be taken care of, and we in open pit face this kind of slope and bench often, quite often, in most of the coal mines. This is basically to give you an introduction, because in rock slope, this discontinuity plane actually plays a very important role for the flow of fluids. Because rock porosity is very less, rock permeability similarly also very less. So generally fluid susceptible to flow along the discontinuity. So along the interrock they do not flow. That is why we need to characterize the joint distribution. Depending on the joint distribution, joint population, joint orientation, we can predict what is the possible flow. So people have empirically tried to give the idea what would be the amount of flow in case of different aperture and spacing of the joint. Empirically different formula is available, you will get this parameter, this is here. So people have tried to do many work on that. Heterogeneous, depends on the heterogeneity of the rock layer. Suppose there is a sandstone, then shale, then sandstone. If this kind of rock layer is there, we observe interference. Interference means suppose light is traveling from a lighter media to heavy media to lighter media, we generally observe deflection. Similarly, flow pattern get this kind of deflection due to the interference of different kind of rock layer, heterogeneity. So this is been represented well by this kind of approach. Means hydraulic conductivity of these two layers would be ratio of this angle change. This is the work. In the book downtown you can find out this figure. These are also isotropic flow. This is based on, suppose the rock have a joint, the joint is not persistent. If the joint is not persistent, then there is a possibility that pore water may remain there. Because if it is a continuous one, persistent one, then there is a possibility that water will flow along this line. So, based on different geometry and joint distribution pattern, you have to predict well what is the possible groundwater table will form, not groundwater table, sorry to use that, phreatic surface. Groundwater table is a different concept. Generally, what we actually use is phreatic surface. And there are numerous methodology to estimate, measure the amount of water flow in a rock joint, not from a rock joint, in a slope mass. So these are the possible. Generally, we use standpipe kind of thing. That standpipe can be fitted with different sensor, good amount of sensor, vibrating wire sensor to pneumatic type sensor that can analyze very precisely the amount of water is developing in a very short amount of difference, minute amount of difference. Because based on the amount of water flow, sensitivity of the sensor also depends. Based on the amount of water flow, we design the sensor. If there is a flow pattern is very small and very sensitive structure, we use very sensitive sensor. For that, transducer is used, electronic transducer, pneumatic piezometer like that. So these are the tests. These are the also field tests to determine the hydraulic conductivity in the field itself. Because this you have to determine this hydraulic conductivity to estimate the possible amount of water flow you are going to face. These are the parameters. Now, after that, one important topic needs to be covered, that is very important. That is dam stability, most probably. Or slope stabilization. Slope stabilization we can think later. First, we should introduce the dam stability. Every time it is creating problem. This is the topic you will find many researchers in our department is working. This is very important problem in mining industry, because I have already told you 6 million ton of the coal here is produced majorly by the open pit mine, and necessarily due to that we are creating a large amount of volume of overburden that need to be reclaimed. And one of the possible method of the reclamation of that large volume of overburden is to dump it outside the mine, within the leasehold boundary. That is overburden dump. I will give you a glimpse how overburden look like. If you visit from Dhanbad, you start visit by road, within 5 kilometers you will see this kind of large dump, overburden dump in different. So it's a big problem. Big problem in the sense we have reviewed the number of accidents in India in last 5 to 6 years. A large number of accidents is occurring. And the recent one is there in 2017 near Dhanbad. One Daga, what is the district? There is a large failure in the month of December 2016. In 2017, it was revealed in the newspaper. Few crore machine been stopped because all the mass flowed like water. There is a liquefaction of it. Whole lot of mass flowed and stopped the machine. Whole lot of machine, and there are large number of fatalities also. And citing that, our agency like DGMS have suggested that you need to take care of this, and yearly basis you have to analyze the stability condition of this system. So you can easily understand this is a loose material. At this today's time, 2019, 22nd October, we have experienced height of this loose material dump height up to 220 meters in NCL. You think about 220 meter height. Maybe it is already up by few meters again. 220 meters height of this loose material. Can you think about handling this kind of material for 10 years? It's loose material, there is no compaction. So it's a very challenging problem for the mining engineers, and we need some solutions. Many people are working on that, and we are trying to give some solution to the industry also. These are the kind of feature we observe in the base of the dam, because in the dam material is dumped on the top, so it is observed that the large boulders is rolled down to the base and the small material stay in the crest. So this gives a hint. This gives a hint that this rock material is not continuous. Type of movement for the block, type of movement for the loose material is different. So there is a differential movement between the material I am dumping at the top of the bottom down. So this need to be taken care of by suitable numerical methods. That is why nowadays continuum based numerical methods in critical cases could not accommodate the failure generally observed in this kind of slope. That is why I will share you one information. This you can see a large cracks in the slope surface overburden down. This was observed in 2010 in Western Coalfield Limited in near Umre, and there is a 4 meter down movement in the top, and by chance the movement is towards the outside periphery of the mine leisure road area, so there was no fatality. And for the information, that is why I shared this picture. At that time, we generally we are working with the discontinuum based numerical method, that is TFC. It is a method, one software is developed by Itasca. There are many other products also. One of the important product they produce using particle nature of material, particularly for the geomechanical problems we see. We use that 2D, and we predicted pretty well 4 meter amount of crack before the incident, 1 month prior to the incident. That is why mining company have taken care of this matter, and no fatality also. So the purpose for sharing this information is that numerical model is nowadays is so strong. If you model it accurately, that accuracy is necessary, precaution is very necessary, care is very necessary, how you are taking care of the physical condition, field condition to the virtual one, that model will give you a very good result, that is you can observe in the field. So we could predict for amount of displacement. There is another report we found from the literature, this kind of failure is observed in Greece, not Greece or Turkey. Greece or Turkey, one I may conflict. They have also, oh yes, team is very famous for this work. Richard Ulase, he is the now president of ISRM. Their team predicted a very advanced this type of failure. This was published in most probably in 2009 or 2008. That time you were doing PhD. So that is why I remember this failure. Now, for characterizing, for analyzing this kind of slope, we need to take care very sensitively the characterism of the dam material. But there is a big question. Big question is there is no standard procedure to characterize the dam material. Still, it is not generally agreed procedure. Few countries, particularly in Australia, they have come up with some idea, some rating kind of system or some kind of methods. I forgot that they have come in our institute also. They have shared their information. But globally, what should be the type of material? Which material will taken care of? How much amount will taken care of? This is a great controversy. We generally take this problem in this kind of software. So these are the facilities we already have. We have already seen that in our laboratory. We have tried to do that in our laboratory. This is also an equivalent material modeling for the slope stability, dam stability. From that, we can determine the type of failure, shape of the failure using that. One possible formulation I will show you. Yes, this is a very important step for characterizing the dam slope mass to prepare the sample. This is observing the triaxial setup. This case study was, I forgot the place. Most probably, most of the work is in Western Coalfield Limited. So this is all. So if you have
does the geosynthesis serve the purpose of safety?
may some up to some limit, because in Indian experience I can share you. There are two approaches in mining. In dam stability, one team have tried to give this kind of what is we call it, the red color. What do you call it? So if I lay the scarp on the wall, so the scarp actually gives some amount of resistance to the rock wall. Similarly, if I lay this kind of scarp, very fine scarp made of synthetic, means it will not last. Possibly some amount of resistance it will offer. Possibly some amount of resistance it will offer. But that will depends on the magnitude of the problem you are facing there. For a small slope face, it is possible that with that laying the geosynthetic grid, you can do good amount of job. While I was in IIT Kharagpur, we are associated with this kind of work, and we saw for a small slope, suppose a 10 meter up to 20 meter, 30 meter high, total, there is bench. Here you can think about that. But beyond that, in a mining, we generally now working 90 meter, 110 meter, 120 meter, these are the height. Oh, it is very difficult because local failure is continuously going to happen. So geosynthetic grid, of course, geosynthetic grid made of which material also is a very important parameter. What is the grid size you are going to take care of? So we can do numerical modeling before installing this kind of geosynthetic grid on the slope, on the loose material. We can test it and we can conclude something about the future prospect of using this geogrid for the possible stabilization of the downslope. We can do that. We have that. Any other question?
And the parameters, when we consider water infiltration in dam, considering the very heterogeneous
For each in dam. One possible answer would be what we have done. I will share my experience. We have done a big project comprising 11 mines of the WCL. 11 mines are located around 300 meter, 400 meter in this radius. There are 33 dams we are taken care of in the study. And 33 dams is in different zone, that is why soil composition and dam material is also different. Not only that, type of blast material means type of explosive they use, production explosive, and over the blasting the overburden dam is also different, so grain size is also different. Then we thought of a method. The method is like this. Then we thought of a method. Generally, what happens? In a dam, suppose this is a dam. If we visualize the microstructure, that is not visible. If you think about the microstructure of the dam, think about the microstructure of the dam, it will be this kind of things. Though not equal, but schematic diagram. It represents what? It represents different block size. So different block size have different kind of strength. Not only that, it is encompassed by different fine grain material. Okay. So when you are considering the stability of this slope, obviously we have to characterize the geometrical mass, because we have learned from the analysis day one that strain is basically the constitutive matrix into the stress. So you know the stress, so you need to know the constitutive matrix so that you can predict what is the deformation. So it is basically the delta is basically the constitutive matrix C into force stress. Yes. This kind of things you need to. So determination of this C constitutive matrix is very important. So your question is basically how I can characterize this kind of heterogeneous material. That is what I have shared you one information that in India, not only in India, globally, there is no standard method to characterize what should be the best and scientific procedure for characterization of this kind of material. But people are working and people are getting good result even though they do not know. We do not know. But what we do? We collect soil material only. We consider that generally when failure is occurred, basically we found that failure is occurred along the loose material. Not along the block. No block is broken. How we are telling that? Because from this today's laboratory test, you have already seen that if there is a movement along a two plane, there is some amount of rupture developed. So from the failure plane, we can predict which kind of movement occurred. Whether that movement have broken the block or not. Generally, it is not. Answer is no. So general failure pattern is along the weak material, that is fragmented, very loose material and soil. So what we do in this case, we generally segregate rock and soil separately, and we try to find what is the amount of composition of the soil in this kind of dark material, and then we try to characterize the soil using ASTM methods only. How they are preparing the sample for testing direct shear as well as for the triaxial setup. That is why I have shown you some sample of the triaxial setup, and we observe a truly shear plane. And that you need to take care of when you prepare that kind of soil sample. You need to measure the OMC of the material, and you have to prepare the sample at OMC only, because you have told there is a problem of water. So generally from the literature what we observe that OMC plays a very important role. At OMC condition we are testing, it is the highest dry unit weight. So at that condition we will prepare the sample and we will test it in the triaxial laboratory. Similarly also we will try to test the sample in direct shear, so that we will try to find out is there any difference. Generally there is difference is observed, but we take care more accurate result as the triaxial test result, and that will serve you the purpose, the C and phi of that particular heterogeneous material. Even though material is heterogeneous, what we are determining in the lab for characterizing this kind of rock mass is we are taking care of the homogeneous sample of small fine soil only. Because of what? Because it is from the dynamics of the movement of the slope mass it is observed the failure is generally through the loose and weak zone only. Of the assembly of this kind of rock, you can easily say which is the most weak zone of this rock mass. So for this case basically we approximate, we compromise. Okay, we characterize the loose material soil, and that will serve my purpose. Till today it is serving the purpose. I don't know the future, because definitely future is else. Future is different. Future scientists always seek for a truth. So we have to find out the truth. That is why one good good work being developed by a university in Chile. It's a very big university in Chile, where in the next year in 2020 Mass Mine Congress is a very big mining congress. In every 4 years it is held in different parts of the globe. They are going to host that mining symposium, Mass Mine 2020. You can think of that. In that university, they have the facility to test the overburden dam material of any size. Their size is 1 meter. Their sample size is 1 meter radius. Triaxial test setup, 1 meter radius they have developed. The room is this kind of, the laboratory is this kind of room. Big room, factory type room is required to test a material of 1 meter radius in triaxial. because there is no standard. They have developed their own standard and they are working very well. Because why it is required? In Chile, at present day, they are operating the deepest copper mine in the world. They are also facing a similar slope stability problem in their country. So that is why it was required and they have developed. 1 meter radius sample can be tested in Traxial. I cannot thought of it, but they have done it. It's a big, big challenge, and science is advancing into this kind of bold step. And hope you people will do in future this kind of things. Okay?